We live in a dramatically altered landscape. Human settlement has been here for hundreds of years. We've altered our rivers and we've built human communities next to our rivers.
Vermont has lost half of its natural wetlands. And with that loss comes a devastating loss in ecosystem services and benefits that they provide. These services include reducing the severity of floods and improving water quality.
The state of Vermont's plan for meeting the goals of the Lake Champlain phosphorus TMDL include restoring wetlands and increasing the level of protection for existing wetlands. Organizations like the Nature Conservancy and government agencies such as the U.S. Fish and Wildlife Service and the Natural Resources Conservation Service are working to conserve these valuable nature-based solutions to water quality challenges.
The La Platte is one of those really special wetlands that we protected in the 1970s. La Platte Preserve is really only 245 acres, 45 acres of which are intact floodplain forests that are submerged for over a month in the spring.
The La Platte is the last stop for the water before it enters Lake Champlain. So the wetlands at the mouth of the La Platte act like kind of a sponge, and they're filtering out nutrients and sediments before the water gets to Shelburne Bay, where, in the bays, because those are shallow waters, there's a tendency to have algae blooms.
We know all of the benefits of nature. Nature provides clean air, it provides clean water. But in order to make a convincing case for lawmakers and people who are going to be making investments in the TMDL, in reducing phosphorus, we need to be able to quantify the benefits of nature.
For example, we've had a 2-year relationship with the Gund Institute for Environment at the University of Vermont.
We're taking a combination of approaches to try and pin down the phosphorus retention in these systems, both through soil sampling, analysis of vegetation and growth of biomass over time, live plants and trees, and also by monitoring the changes in phosphorus concentrations in the water during storm events.
And we asked them to look into the question, how much natural systems, how much wetlands and floodplains would we need to restore in the Lake Champlain Basin in order to reduce the phosphorus levels in Lake Champlain?
We do numerical modeling, simulating the processes occurring in these wetlands to try and estimate through the process modeling what the phosphorus balance is.
We found that we could achieve up to 15% of our total phosphorus reduction goal by restoring these wetlands. What we've learned through some of this research is that nature is one of the most cost-effective solutions to addressing our water quality challenges.
The future of Lake Champlain's health is partially dependent on our healthy wetland natural communities. They're part of a suite of solutions to really achieve clean water progress in Lake Champlain.
That means we all have a role to play in protecting and restoring the natural systems that can solve this problem.